champ, how are you doing? Welcome into class and I'm your master teacher Shivam Gupta. So champ, I was thinking about this question. What do you think? That Jack is approaching a cyclone, right? And he needs to turn his ship by an angle to escape the cyclone. Can we find that angle? Can we help the Jack to decide that angle? What do you say? So champ, the answer of this question we will be looking at in today's class. So champ, in today's class, we will be looking at the properties of the tangents and many important questions on the same. So let's get start. So in today's class, we will be looking at the different properties, different kind of concepts according to the tangents. So champ, let's consider one condition. Let's say that point P is any given point and we have a line AB also. So now we can see the point P and a line AB has a different distance, like a distance PS, the distance PQ and the distance PR also, right champ? So bache, can we find out that out of these three distances, which one is the shortest? What do you think? Out of PS, PQ and PR, which one is the shortest distance? I hope that you have guessed right? It's a PQ. Why? Because the perpendicular distance is always the shortest distance. Right, champ? Very good. In the same way, now let's consider a circle. Okay? And let's say that we have a tangent AB at a point P and we have any point on the circle Q. So we can say, champ, OP equal to OQ. Why so? Because both are the radius. If OP and OQ are equal, so can we say that OR is greater than OQ? We can see very easily. OR is greater than OQ. If OR is greater than OQ, then OR is also greater than OP. Why? Because OP and OQ are equal. That means OR is greater than OP. We can say the OP is the smallest distance. OP is the smallest distance of the point O from the tangent. And we know that shortest distance is always perpendicular. Right? So champ, from here we can say the tangent at any point of a circle is always perpendicular to the radius through the point of tangency. That means the angle OPB and angle OPA is always 90-degree angle. I hope it is clear. Now look at this example. As we know that tangents are always perpendicular, so that angle has become 90-degree. Yes. Now we can apply the trigonometry here. We know the angle, we want to find the angle sine theta perpendicular upon hypotenuse. We know the perpendicular, we know the hypotenuse. Sine theta is equal to half and we know sine theta is equal to half at theta equal to 30-degree. Easy peasy, I hope it is clear. Very good. So now champ, it's a quiz time and you have to give me one answer. So look at the question. And what do you think that a circle can have maximum how many tangents? Come on, hurry up. A circle can have how many maximum tangents? And your time is up. And the answer is infinite because we know that at every point we can draw one tangent. And circle is nothing but the combination of infinite points. At one point, one tangent. At infinite points, infinite tangents. Right? The next question. How many parallel tangents can be drawn to a tangent passing through a given point on a circle? That means on a circle, we have a tangent. Now you have to tell me that with respect to that given tangent, how many parallel tangents we can draw. Come on, hurry up. I hope you are done. And your time is up and the right answer is 1. Only one parallel tangent can be drawn with respect to the given tangent. It's very simple. Yes? Very good. So now champ, let's discuss the tangent from different points. That means it depends on the position of my point also. If my point P lies inside the circle, then there could not be any tangent passing to the point P. Yes, because it will be my secant. Yes. Let's say my point P lies on this circle. If point P lies on this circle, that means point P is the point on the circle, and on this circle we can draw one tangent with respect to every point. So one tangent is possible, right, champ? Now in the same case, if my point P lies outside the circle, then in that case we can draw two tangents from the outside point P on the same circle. I hope it is clear to you. Very good. Now champ, a very important question to think about. That if point P lies outside the circle, so there are two tangents, PA and PB are the tangents. So can we say that if the point P lies outside the circle and PA and PB are the tangents, then the length of the tangent from the same point has to be equal? Let's figure it out. So champ, let's consider the same figure, that from a point P we are having two tangents PA and PB, and we want to prove that PA equal to PB. So now champ, in the chapter circle, our maximum number of theorems, maximum number of concepts we can prove with the help of the concept of congruency of the triangles. So champ, what we can do, let's construct two triangles by joining AO, BO and PO. We are having two triangles, triangle AOP and triangle BOP. One angle is 90 degree. Yes, angle PAO and angle PBO are 90. Why? Tangents and radius. Yes. Now in the two triangles AOP and BOP, we can say one angle is equal, AO is equal to OB, both are radius, and PO is common. So with the help of RHS criteria, both the triangles are congruent, right? If both the triangles are congruent, their corresponding sides must be equal also. That's it. So champ, in this circle chapter, we only have to apply congruency and similarity concept. That's it. So by CPCD, we can say PA equal to PB. I hope it is clear. Very good. So champ, very important concept. The length of the tangent from an external point to a circle always equal. That means PA equal to PB. Okay. Very good. So now champ, let's summarize our class. So champ, in this class, first of all, we have seen that the tangent at any point of the circle is always perpendicular to the radius. But which radius? The radius to the point of tangency. This point P is the point of tangency. This is the point where we are drawing the tangent. At this point, draw the radius. Tangent and radius will be perpendicular. After that, we have seen that it depends on the position of the point, that how many tangents we can have. If the point lies inside the circle, we cannot have any tangent. But if point lies on the circumference, then we can have one tangent. But if point lies outside the circle, we can have maximum two tangents. And in the last, we have seen that if a point P lying outside the circle, we are having a two tangent PA and PB. Then both the tangents will be having the equal length. That PA will be equal to PB. I hope it is clear. All are very important concepts. So make sure that you are practicing hard also. So champ, that's all for this class. Stay tuned, be curious and keep smiling. Bye-bye.